Hi, everyone. Welcome to day 3 of our Moving Research Online workshop. My name is Josh DeLayu. I am an assistant professor of cognitive science at Vassar College. And my co-presenter today is Becky Gilbert. So Becky, you want to say hi?
Hi, everybody. I am Becky Gilbert. I'm a postdoc at the MRC CBU at the University of Cambridge.
Great. So today's session is covering more advanced features of jsPsych. And just to sort of reorient to the format of these sessions, Becky and I are going to be doing some live coding examples today. We're going to try to get through three different sort of topics. And while we're doing that, if you have questions that come up, please use the chat window that's to the right of the video if you're watching live on YouTube on a desktop computer. We have members of our team will be monitoring the chat, and they'll try to answer questions directly in the chat when possible. And if there are questions that make sense to answer live on the stream, they'll forward those to us. And we'll try to get to as many of those as we can live. But we also have a session on Thursday from 1 to 5 Eastern time, where we'll all be available to answer questions in our discussion forum, the jsPsych discussion forum. And this is linked to on the Moving Research Online website, which is movingresearchonline.info. Speaking of that website, I'm just going to jump over there right now, because one of the things that we've done for today's session is to, so I'm just making sure my screen is shared. Okay, I'm going to switch over to website. One of the things that we've done for today's session, in order to be able to cover some of these more advanced features without spending too much time going back over what we covered in session 1, is that we've created some starter code if you're trying to follow along. So if you're interested in following along today, especially the second part of our presentation, where Becky will be walking through the creation of an in-depth experiment, we recommend that you go to the website, and under session 3, there is a link to a GitHub repository, code repository for this session. And if you click that, this will take you to a GitHub repository. And what we recommend that you do is click this green code button and download the zip file. I'm actually going to go ahead and do this now myself. And I'm going to open this up, and I am going to extract this zip file just to a folder. I'm going to put it on my desktop. This is going to take a minute. Inside this folder, we also have all of the code that we worked through in day 1 of the workshop. So the Hello World example that I went over, and also the lexical decision task that Becky built. Those are the complete code for all of those is available in this folder as well. So I'm going to go ahead and open it up. So in the day 1 folders are the content that I just mentioned. But today we're going to start with some discussion of functions in jsPsych and when jsPsych code runs, because this is the trickiest thing to sort of get your head around, I think, when you're new to JavaScript and new to jsPsych in particular, is when does your code actually execute? And this turns out to make a really big difference in terms of how you structure your experiment. And it's sort of the key that unlocks all of the more advanced features of the library. So you don't need to necessarily open this up on your own computer right now. So don't worry if it's still downloading. It's really for the second part that you'll need the code. This code is actually already just completely written, and I'm just going to walk through it. So I'm going to open it up in my code editor. And I'm just going to set things up so you can see as much of my screen as possible. OK, so what I've got here is a very sort of simple experiment or quasi-experiment, kind of the early stages of building an experiment. I've sort of done the things that we talked about last time. I've loaded the jsPsych library. I've loaded a plugin file here, the HTML button response plugin. I've loaded a style sheet, the default jsPsych style sheet. And I've created a pretty simple experiment here that I'm going to walk through. So in the experiment script, I have created an empty timeline, an array. I've created a single trial here. So this trial is using the HTML button response plugin. It's got two choices, so two buttons that are going to be generated on the screen. One button is for word and not another button's for non-word. So we're doing another kind of lexical decision demo here, except this time it's buttons instead of keys. And then my stimulus parameter is actually a function. So I've got this function called generate random stimulus. And that's what we're going to be talking about more in a second. Then I've added 3 copies of this trial to the timeline. So we'll get 3 trials that will be running. And then just for illustration or pedagogical purposes, I've added a console.log message that will, when we get to this line of code, it's going to say that we're about to initialize the experiment and it will begin in, it'll begin in the next line. And then finally, I call jsPsych.init and pass in my timeline object to launch the experiment. By the way, let me pause here for just a second. If jsPsych is new to you and you didn't get a chance to come to day 1, we're not going to be able to work at a pace to sort of reintroduce everything. We're trying to sort of pick up where we left off. The good news is that our video content from day 1, it's recorded, it's on YouTube. So you're welcome. I would encourage you to stay and watch this and pick up what you can from it. But then you can always go back and watch day 1 again. And hopefully that will give you a chance to get up to speed. Okay, so we've initialized our experiment here. And then here's the critical thing that we're going to be doing. We're using this function to generate new stimuli. So we're going to generate some random stimuli. And what this function does, it's pretty straightforward. I've created an array that contains all of the letters of the English alphabet. And then I'm using a function that's built into jsPsych in the randomization module, and it's samples with replacement. So just picking 3 letters, allowing for repeats from the alphabet array, and we're gonna pick 3. And once we have that array of 3 letters, we're gonna convert that back into a string. So we don't want literally an array of 3 letters. We want the string ABC. So this join method here allows you to take an array and join the characters back into a string. And the argument here, this empty string, is what to put in between. So if I put a space here, it would do A space B space C. But by having nothing here, I just get the word. Okay, and then finally, inside this function, I've got another console.log to just register that this function has been called and also sort of output the word that was recorded. And then the function returns the word. So when we call this function, the output of the function will be the 3-letter random word that we've generated. Okay, so what's going to happen here? Well, we're gonna create this trial. We're going to create a stimulus. We're going to run the trial 3 times, and we're going to see what happens. So let me go ahead, and I'm just going to open this in Chrome. Okay, so the random string that we got is PDY, so non-word, PDY again, non-word, and PDY again, non-word. So this isn't just a coincidence. We didn't happen to get the same 3-letter string each time. It's actually that the generate random word function is only being called once. And let me open up the developer tools. So we talked about this last time, but you can, in any browser, you can open up the developer tools and gives you access to the console where we can see those messages that we were creating. So here's the generate random stimulus function being called, and it's saying that the generated word is PDY, and it's only called 1 time. And then we get the message that jsPsych is jsPsych.init is about to be called and the experiment will begin. So this function gets called before the experiment begins. So let me pop over into the code. So what's going on? Well, what's happening is that whenever you set up an experiment in jsPsych, all of this code here is running before the experiment actually begins, right? There's kind of like a setup phase. You're building the structure of the experiment, and then at the very end of that, you're telling jsPsych, my experiment's ready, go ahead and run it. And because you're constructing all of this at the beginning of the experiment, this stimulus function is actually getting called as soon as you create the trial. So when you create this trial variable here, this function gets called immediately. it generates a 3-letter string, and that 3-letter string then becomes the stimulus parameter for the trial object. And then we add 3 copies of that onto the timeline. So we get the same exact trial 3 times, and then we see the experiment. Okay, what if you wanted to actually generate a new random string every time that the trial ran? That would be far more useful. Well, one thing you could do is you could do like a for loop here, where you construct lots of trials at the start of the experiment and you add all of those on sequentially. But another thing that you can do is, instead of passing the output of a function like we're doing here, where we're calling the function and then passing the output as the parameter, we can also just pass the function itself. So we can, instead of having parentheses here to call the function, we can give it the name of the function. And by giving jsPsych the name of a function and actually making the parameter stimulus a function, that dramatically changes how jsPsych handles the code. So I've just done that one small change, and let me go back over to this demo. I'm going to refresh. Okay, so over here in the console, note that the experiment will begin message is now appearing first. And then we're getting a generate random stimulus message with the generated word. And then I'm going to click non-word. And then right before that trial began, we got this function again. And we got a new word. And then we get a new one again. So the difference here is that when you use a function as a parameter to jsPsych, that function is not executed until your experiment is actually running. So by passing in the function, you delay the execution of the code until right before the trial begins. And this opens up lots of possibilities. Here we're only sort of barely taking advantage of it because we're just using it to generate a bunch of random strings. And we could, in theory, we could all do that at the beginning of the trial too, by writing a loop or something like that. But if we wanted the generate random stimulus function to be, say, conditional on what has happened before, so say if the last 4 words were non-words, then make sure that we include a word or something like that. We could write that logic into this function, and we could make our experiment responsive and adaptive as it goes along. And as Becky works through a more in-depth experiment today, you're going to see some examples of how functions as parameters really opens up the possibilities that you can do with the jsPsych library. Before I turn things over to jump into that experiment, I just want to quickly highlight one more way of constructing this stimulus argument here, the stimulus parameter. And this is something that you'll see a lot in jsPsych code, which is that instead of having the name of a function here, we could actually construct the function right in the parameter. And we can do this through what's called an anonymous function. We can define the function keyword with the arguments that we're passing that function. Here would be an empty set of arguments. And this doesn't have a name. There's no way to reference this function. Well, we could do it through trial.stimulus, but there's no name here for this function. And what this allows us to do is just sort of, if we don't really need this extra line of code, if we want to sort of keep things together. So I'm just going to show this by copying this function code and putting it up in here and saving that. So this is another way to do exactly the same thing, that we can just create the function right here as part of the stimulus parameter. So I'm going to save that. I'm going to open this again, and we can see that we still get 3 distinct strings. Okay, so that's my very sort of brief overview to understanding when functions are going to be running in your code. While we sort of transition over to Becky and the experiment, if there are any conceptual questions about this, this would be a great time to throw those in the chat. And then Becky's going to give some more concrete examples of how this applies to an experiment.
Thanks, Josh. We do have at least one question. Somebody asked why is it that you can create the function all the way at the bottom of the script after you've used it?
Great. Let me revert back to how I had this before. Okay, so in JavaScript, when you create a function with the function keyword here, it doesn't matter where you put it in the file. that function is available throughout the file. Essentially, the JavaScript engine will, the first thing it will do is find all the functions and create them. And then it will, those are available throughout the file. Now, there is another way to construct a function that you'll sometimes see in JavaScript. So instead of doing function generate random stimulus, you can also do it like this. You can do variable generate random stimulus equals function. And then you could put the function code in here. Now, if you do it this way, because you're using this variable syntax rather than this function syntax, then the order does matter. So you would actually have to put this at the top of the file, or at least before this point in the file, in order for it to be available to use at that point. So great question. Thanks for bringing that up.
Yeah, and I think we have time for one more. Somebody's asked how you could pass arguments to your functions if you needed to, or would this be like a bad idea? Should you not do that?
Yeah, so that's a tricky question. So you could pass arguments. I didn't really think of a quick way to do that. I guess we could quickly show, what if we could do a length argument, right? So we could, oh, that's not how you do it. Coding on the fly. All right, length. And let's make this, instead of sampling 3, we could do length. And then what I could do here is I could say I want 7. These are all going to be non-words. There's no hope. So we could do open this. And so you can see we get 7-letter non-words. But the problem is that we're going to get the same 7-letter word every time. And this is kind of the tricky part, because if we want to now get rid of this so it generates a new, we can't easily pass an argument in here. So one thing that you could do, and this is kind of a weird workaround, but it's maybe the simplest way to do it, is you could create another function that called the generate random stimulus function, and you'd have to return that like this. And this would give you a way to randomly construct 7-letter words, or all non-words, I'm sure. Yeah.
Great. So if you read it that way, I think, would you need to pass that 7 into the anonymous function, or is that not?
No, I think so. Like you'd have to, the anonymous function here is kind of serving as the wrapper to allow you to pass an argument in here. Maybe somebody who's watching is more up to date with like modern JavaScript than I am. Maybe there's a way to do this that I'm not aware of. But this is how I default to it. I just sort of create an anonymous function and then pass my arguments in, and just sort of use this as a wrapper to allow me to pass those arguments in.
Got it. Sorry for the tricky question. One more. Is there any advantage to using an anonymous function? Somebody thinks it might seem a bit messier. Do you have any thoughts on that?
I would say totally personal preference in terms of what you think is messy versus not messy. So sometimes I prefer anonymous functions when this is the only place in my code that I'm going to use that generate random stimulus function. If I'm debugging, I might want everything kind of in the same location, rather than say having to scroll down to find the definition of the function and then go back up or something like that. But if I was going to use this, generate random stimulus method in multiple places in my experiment, I would absolutely, write it like this so that I don't have copies of the same code in multiple places, because that makes debugging even harder. Because then if you fix it in one place, you have to fix it in the other place too. And sometimes the other thing to just mention is that sometimes anonymous functions are like here, right? This is such a short function that I think it would actually make the code less readable to extract this out, and actually it would defeat the whole purpose of sort of being able to modify the parameter right here in place. So I think sometimes anonymous functions are really useful for these one-off short kinds of things that you want to do that are affiliated with a trial. We saw some of this last week, by the way, just to mention this again. So one of the things we saw last week was the onFinish parameter, which, unlike these parameters, which can be functions or not functions, and the point here is that by making it a function, it can be dynamic, onFinish has to be a function. It has to be a function that can take in the data. And here, I think, like, you could also write a function that says like handle onFinish or something like that, and then you could define that elsewhere in the script. And if that seems cleaner to you, go for it. There's no reason not to. But for my personal preference, I would want to have this here so that it's all like all of my trial object is contained in the same place.
Great, thank you.
Okay. All right, I'm going to pass it over to you. I'm going to stop sharing.
Okay. Okay, so at this point, we're going to talk about a few jsPsych features that we haven't talked about yet. And so Josh so far has been talking about using functions as the values for different parameters. And so this can make your experiment more dynamic because you don't need to necessarily know what the values of your parameters are going to be in advance. You can figure that out on the fly during the experiment. So another thing that jsPsych can do, it can help you do, is construct your experiment so that the structure is actually dynamic. So that you don't need to necessarily say that everybody's going to do all of these things in this particular order, but you can actually change the structure of the experiment on the fly. And that's, again, using functions. So to do that, we're going to be talking about two jsPsych features. So I'll just show these to you now here. One is, there we are. So this is an overview and then creating an experiment, the timeline. In the last session, we talked about kind of creating single trials and multiple trials, and we talked about timeline variables. And so now we're going to be talking more about looping timelines and conditional timelines. So these are ways of creating an experiment where you don't necessarily know what you want the person to do in advance, and you want to determine that during the experiment. A few other things we're going to talk about is version randomization. So if you've got multiple versions of your experiment, how you can manage that. And hopefully we'll get to the point of also being able to show some feedback about the person's performance at the end of our task. So what we're going to do is start with some code that's already been written. So if you're coding along with us inside of your Moving Research Online Workshop folder, there's a folder in here called Day 3 Semantic Relatedness. So this has got a pre-written file in here that does a little experiment, and it's called Semantic Relatedness Start. So we're going to open that up, and we're going to do some modifications to this. And hopefully by the end of it, we'll get to the point where we have where we are in this other file called finish, but that's in here too if you want to reference that. So I think what I'll do is go into my text editor here and open up that start file. Okay, so Day 3 Semantic Relatedness, and then I'm opening the one called Start here. And I will just talk you through this code, but I think maybe what we'll do to start with is actually just run this so we can see what's inside of it. So, and I'm just going to open up the console log out of habit here to keep an eye on any errors. Okay, so we get some instructions here. In this task, you'll hear a spoken word, and then you'll see a written word. And the task is to press the J key if the meanings of the two words are related, and press the F key if the meanings of the two words are unrelated. You can press next for more instructions, and we get some examples of related word pairs with related meanings and unrelated meanings. Now, if we click start, we will get 3 practice trials.
Flower. Jam.
And feedback after each one.
Town.
Okay, then we see a message saying, great, you're done with the practice, and then we move on to the main task. And I will just go all the way through this, so bear with me, it's 12 trials.
Straw. Toast. Fruit. Knee. Pen. Zoo. Mouse. Axe. Cheese. Crowd. Bark. Calf.
Okay, then finally at the end we get thanks, you're done with the task. So I'm going to go back to the code here and we'll talk about what's in here. And almost everything in this file is things that we covered in the first session. There's a few things that are new, and I will just highlight those at some point as we go along. So we're creating the task here. We're loading in the jsPsych files that we need, which is the core library and some plugins. And then you'll notice I have 3 scripts here that contain some trial information. So I'm going to go ahead and open one of these. So I'll open up the practice trial information so you can see what that looks like. And this is in the JS subfolder called practice trial info. And what I've done in this file is just created an array called practice trial info. And this contains the set of objects that I am going to loop over in my timeline variables to run my practice trials. So again, timeline variables we talked about in the last session, so I won't say much more about this. I think before maybe what we did with lexical decision is we created this information in the main script. And here I've just I created this array and put it in a separate file just so just to make my script a bit shorter. But because we're loading it here in the head section, we now have access to that variable in the main script. And I'm doing the same for these 2 files here. I have one called trial info v1, and then I have another one called filler trial info. And these 2 files, when they're combined, make up the all of the main task trials, the set of 12 trials in the main task. And I'll say more in a minute about why those are in separate files. Okay, so in here we're creating the empty timeline that we're going to add to. We are creating our main trial array here, and we're doing that by combining those last 2 files I mentioned, one called trial info v1. And then we're calling this concat function, which is going to take another array and just add it onto the end. So the result of this is the combination of these 2 arrays together, and those make up my main trial information. And I'm going to skip over this bit of code here for now. This is to do with audio preloading. We'll come back to that. Now we're creating some instructions, and those get added onto the timeline. And then here we're creating each of the objects that make up the main trial. So the fixation cross, the target, the probe, and then in the practice, we also have some feedback. And if we go back through these a little bit, you'll see this should look familiar from the last session. Just a fixation using HTML keyboard response. And you can see also we're using timeline variables here. So we're adding things to the data from our trial array. The target word is the first word, the spoken word, and this is using an audio keyboard response plugin. And so it's grabbing the audio file from our trial array, and then again, adding some things to the data. Now here's our probe. This is the written word on the screen. And a couple things to note about here. So this is where people are actually making their response. So here we have some key choices, F and J. Again, we're loading in some data. We're actually scoring the response here because this is where they're responding. So when this trial is finished, we can check the accuracy and then put that value, true or false, into the data for this trial. One other thing to note about this probe trial is that we have a function here for the stimulus. So this is an anonymous function, and it's actually using timeline variables. So I don't think we've seen it used this way before. So this is grabbing the probe word, which is specific to the trial. And it's actually taking that and combining it with some other HTML here. So span tag, and then it's the word that's specific to this trial, and then another span tag. So to do it this way, if we want to access these timeline variables inside of another function, like I've done here, we just need to add this true argument onto the end. So this will give me back the word immediately for this particular trial, and then I can combine that with these other strings, and then that whole thing becomes my stimulus for the trial. So here we have the feedback. This is for the practice trials. Again, we have a function as a stimulus parameter because we don't know whether we should be showing them the correct or incorrect stimulus. So inside this function, we are creating a variable to store that, initializing it as incorrect, checking whether their response was correct or incorrect, and then if necessary, changing that to be the correct message. And then finally, we return that text, and that becomes the stimulus. So hopefully this will be familiar to you because this is the same way we did it in lexical decision. But if not, don't worry, you can always go back and watch that. So those 4 objects that I just mentioned get added into this timeline procedure because we want to repeat those for every object inside of my trial info array here. Got these 3 objects. So that procedure then gets added onto the main timeline. Then we create this message saying, great, you're done with the practice trials, you're ready to start the task. And then here we're creating the main task procedure. And this is very similar to the practice, except now we don't have the feedback message in our timeline. And we're also now using the main trial information rather than the practice. And then finally, we're just showing an end screen that lets people know they're done with the task. So there's a few things that are different, and we'll talk about those here in a second. In the jsPsych init function, there's these 3 lines that relate to audio that we haven't seen before, so I'll come back to those. But otherwise, this should look familiar. We're just giving this a timeline, and then in case we want to look at the data, we have an onFinish function that will show us the data at the end. So what I want to do now is show you a little bit about version randomizing. And then after that, we'll come on to the audio stuff that we haven't talked about yet. So if we actually open up another stimulus file, I'm going to go into the JS folder again, and I'm going to open the first one that says AMP trial info v1. So at the moment, this task will always use the same trial information. And if I was running this as a real experiment, these are the trials I would be interested in. So the target word is the first word. And what you'll notice is that all of these are actually ambiguous words. They're words that have at least 2 or more meanings. And what we can do is use this task to look at the relationship between, we can look at the speed of accessing for each of these words, the different meanings. So we could look at the speed of accessing the dominant meaning, like the dog meaning of bark. And we can also look at the speed of accessing the subordinate meaning, which is the tree meaning. So I've got my 6 ambiguous words in here, and these make up all of the related trials in my experiment. And if you're a language person, one thing you might be familiar with is the fact that we don't want to repeat the same items. Oftentimes, we don't want to repeat the same items in different conditions within the same session, so for the same participant. Because if we show bark or play bark and then pair it with a dominant meaning and then later on with the subordinate meaning, then that exposure the first time will have an effect again. So what we're doing is we're kind of splitting up our items and then assigning them to only one condition and then creating different versions of the experiment so we can have all of our items paired with all of the conditions across all the different versions, and so across different participants. So what this means is that for some participants, we want to give them this, this information for the main task. And for other participants, we'll switch over to the v2 file. And this contains all of the same ambiguous words, but now they're paired with in the opposite condition. So they're paired with the other meaning, like tree, calf and cow instead of calf and leg. So we can set that up here, and ideally what you would be doing is actually counterbalancing this. So you'd have, if your experiment's on a server, you could keep track of the last version that you assigned, and then every time you get a new participant and you just rotate through your versions. Because we're not on a server here, we're just going to pick these out randomly. But next week is when we're going to talk about Pushkin, which does server-side stuff. So then we can hopefully learn more about how to do the counterbalancing. Okay, so for now, let's set up our version randomization. So I'm going to, right after the timeline, I'm going to create a variable called version. And I want the value of this to just be either 1 or 2. So I'm going to use a jsPsych built-in function for this in the randomization module, like Josh did earlier. And I'll just use sample without replacement, but it doesn't matter because we're just getting one thing. So this needs the array that we're sampling from. So I want it to be, I want either 1 or 2. And then we only want to take one thing from this array. And these sampling functions will return arrays because it's possible that we want to select more than one thing, in which case it would have to be an array. So to make it consistent, it always returns an array. So even though we're just getting one thing, we still have to index this array to get to the actual value inside of it. So we're going to do that. Square brackets and 0 then at the end. So now we should have this version should be either 1 or 2. And then what we can do is create a variable to store our trial information, which is going to be either the version 1 or version 2 information. So I'll just create a variable called trial_info without the version on the end. And I'm not going to initialize that. I'm just going to leave it like that. And then I'll do an if statement. So if version is 1, then we want the value of this trial_info array to be our version 1 array. And we can just do else here because the only other option is that this is version 2. And in that case, we want the trial_info array to be the version 2 data. So that's the same, and then with underscore v2 at the end. Now the last two last things to do here. One is that in this line, we're combining the information from our related trials, the ones that we're switching around. So this now needs to be the same as this variable. So whatever this variable ends up being, either version 1 or version 2. And then we can combine that with our filler trials, which are the unrelated trials. And these are the same for everybody, so that's why I put them in a separate file. Okay, so I think the last thing to do here is I've only actually loaded the v1 file in here, so let's also load the v2, since we don't know in advance which of these we're going to need. So we need to load both of them. And then a nice way of checking this is just to do some console logs. So I'm going to do console.log, and I'm going to print out the version. I'm going to write in text version, so I know what it is, and then comma and the variable version. And that way I can just load the page and check that it's changing. I think I'll also do a console log for my main trial info. So I can just check that when the version changes, the trial information is also changing. So console log. So I'm going to label this as being the main trial info, and then comma, and then the variable. Okay, so now if we go back to our browser, I've saved that. Hopefully, if we reload the page, we'll see which version we're in. We have version 1, at least in my task. And now we can use this arrow here to look at the trial information. We can see we have bark paired with bite and calf with leg. And now if we reload the page, it's still version 1. Still version 1. Uh-oh. Version 1. What have we done? Version 2. Okay, just a fluke. So now I get bark and tree and calf and cow. Great. So go back to the code. I think the next thing I'll do is talk about the audio. So we haven't looked at audio yet. So there's a few things just to be aware of here. This bit of code here, what it's doing is creating an array to store all of the audio files that I need in the whole experiment. So it's looping through my practice trial information array. And for each element, it's going to grab the thing called target audio, which is the path to the audio file for that trial. So it's looping through and adding each one onto this array, and then the same for my main trial information. So now when these two loops have finished running, my all audio array has all of the audio files I need for the whole experiment. And then what I can do is preload them using this jsPsych init option here, this parameter called preload audio. And I can just give it the array for all of my audio files. So now when the experiment first loads, all of those audio files will be transferred over to the participant's browser. And that means there shouldn't be any delays during the experiment when we need to use those audio files. The participant's computer won't have to go to the server and request those, and then we have to wait for them to come back. So this is almost always a good idea if you have audio, images, or video that you're using. And just to show you one thing, you can check this in the browser. So we've been looking at the console tab here in our developer tools, but up here usually there's something called network. If you click on the network, I'm not getting it. Sometimes it's, oh, there we are. Okay. So you can see here what has been loaded. When I loaded that page, it shows me everything that's been loaded into the browser. So it's got all the files I've loaded in the head section, but down here you can see it's loaded all of my MP3 files as well. So that's just showing that it is preloading those files. Okay, a couple other audio things to mention. Right, so we're preloading the audio. We're showing the progress bar, which is a good idea. I think the default is true, but I've just added it. So if you're preloading stuff, that means that your page might load more slowly. So it's probably a good idea to show that so that your participant knows that it's not just broken. We're using this parameter here that says use web audio false. And we need to set this to false when we're working with our experiment in this way, when it's not on a server. And the reason for that is there's a kind of a weird security thing with browsers where it doesn't like loading our audio files in this way. So if I set this back to true, which is the default, and then I try to run my experiment again, what we'll see in the console tab is a whole bunch of errors telling me something about cross-origin requests. Yeah, so it's trying to load each of the audio files and it's saying it's been blocked by this CORS policy. So the way to get around that when you're running your experiment this way is just to set this to false. Now, as soon as your experiment is on a server, you won't have this problem. So you could just take out this line. And what this is doing, it's just determining which way the audio is presented. There's two different ways of doing it. And so it actually doesn't matter that much, but the web audio method gives you a more precise clock with your audio stimuli. So if you're really interested in reaction times, then you might prefer this to be true. Okay, so one last thing to mention about audio before we might make more changes here to this experiment is that most browsers have a policy where they won't let you autoplay an audio file unless the participant or the user has interacted with the page in some way. And this is to prevent like pop-up ads from blaring audio at you. So it's actually a good thing, but in our experiments, often we do want these audio files to start automatically without the person having to start each one. So we can look at this by removing this line here that says timeline.push instructions. If we comment this out, sorry, child here, then what'll happen is that we'll skip over the instructions, we'll get to the fixation cross from the practice, and then it'll try to play the audio file. So let's have a look at what happens if I do that. Okay, so it gets stuck here on the fixation. It won't play the audio, and it tells me that the play method failed because the user didn't interact with the document. So all this means is that if you want to be playing your audio files automatically, just remember to have something to start with in the file that requires like a button press, like our instructions here. Okay, so now we're going to move on to some more interesting stuff, unless we need to.
Yeah, can I just interrupt for just a sec?
Yeah.
So we had a question that I think would be useful to include in the video, which is somebody was asking if there's a way to ensure that you get the same number of participants in condition 1 versus condition 2. And you alluded to this a little bit, but maybe just we could elaborate on that a little bit.
Yeah, sure. So to do that, that's a great question. We would need a server because we need some way of tracking across sessions how many people we have in each version. So a good way to do that is counterbalancing, and you're just alternating one or the other. And then you can even do things like make sure that you're tracking on your server whether your participants actually completed the session. So if they drop out, then you want to adjust your numbers accordingly. So this is all stuff you do need to do on a server. Because when we're in the browser like we are now, we don't have this kind of memory of things that have happened before. So, so hopefully this is something that will come up in the next session. Is that right, Josh?
Yeah. I guess I would just add that, I mean, the reason that you can't do it in JavaScript is because if you think about where this code is running, this code is all running on your participant's computer. And since it's running on your participant's computer, that means that your participant doesn't know how many other people have taken the experiment or have access to your data or anything like that. So you would need something that's running on your own computer that has all the data where you could actually see how many participants are in each condition. And this is a great question to ask next time when we do the Pushkin session. And also, there's been lots of questions like this on the jsPsych discussion forum. So you could go there and see some of the answers, because there are ways to do it. It's just that you need an additional piece of technology that we're not talking about today.
Okay, great. Anything else, or should I keep going here?
That's it. Thanks.
Okay. So at this point, then, I think we're now caught up with this code, in the sense that everything we've done in here, I've either just explained or we've covered in the last session. I'll just really quickly show you a little schematic diagram of what's going on in the experiment at this point, because this might be useful later on when we add some new things to it. So we have this kind of fixed set of events happening, where we have the instructions. This is on our main experiment timeline. We add the instructions. Then we have this trial procedure. So this is using timeline variables, where we do the practice procedure. And that's kind of repeating over these different parts of the trial for our practice array. Then we move on to our start task message. And then we have a similar kind of timeline variables thing down here, where we're doing the main trial procedure. And again, this is just repeating over some information that's in our trial array. So what I want to do now is show you how to change your experiment so that we can actually check the person's performance at the end of the practice trials. We can then decide, should they move on to the main task, or if they get too many incorrect responses, should they have to go back to the instructions and repeat the practice trials? And to do this, we're going to be using those two features I talked about before, the looping timelines and conditional timelines. And so the conditional timeline documentation is here. And we're going to start with this one. So the relevant part of this example is right here. And what we need to do is create a timeline inside of an object. And this is going to contain the things that we may or may not want to run in our experiment. So it'll either happen or it won't. And we don't know in advance whether we want this thing to run or not. And then we're also going to have a conditional function, which is here. And this is going to be the code that runs during the experiment, right before this point. And it's going to say, should I do this thing or not? So doing it this way means that you can use the information that you get during the experiment to decide, should I run this, this trial, this message, this trial procedure, whatever, should I do it or not? And so this can be really useful if you want to, like what we're going to do now, check the person's performance and then decide what to do. And it can also be useful if you want to do different things depending on, say, someone's response to demographic questions. So it's a very flexible tool. You can put all sorts of different things inside of this timeline. And what we're going to do is just put in here a message that's going to say, sorry, you got too many incorrect responses, and you have to repeat the instructions in practice. So again, this is something we don't know in advance whether we want to show that message. So we're going to put it inside of this conditional. So we'll go back to our code here, and we need to put this in after the practice trial procedure, which is here, and before this start message. So let's create we're going to create the message first. So we'll call this repeat prac message. And this is just a normal trial object. So it's using a plugin, and it's going to use the HTML button response plugin. And we need to give it a stimulus. And so this is the text we may or may not want to show. And I'm going to use some p tags here, and then just write, you made too many, I don't know what, write whatever you want here. You made too many incorrect responses. And then in a second line, some more p tags, we'll write in, you will now repeat the instructions and practice. Okay. And then we need a comma there, and then we're going to add in another parameter, which is choices. So this is a button response plugin. So we need at least one button, and it has to be inside of an array, and our button is just going to say next on it. Now, we don't want to put this object on the main timeline, because then it would show up for everybody. So instead, we're going to create a little conditional node. So we'll call it repeat prac conditional. right? And so this is an object. And it's set up a little bit, it might look familiar to timeline variables because it needs a timeline. And then it needs one other thing here, which is the conditional function. And this has to be a function, so we're going to write it like that. And I'll just use the anonymous function, but like Josh said earlier, it doesn't have to be. Okay, so inside of our timeline, this is whatever stuff we may or may not want to happen. And in this case, it's just going to be this one message. It's going to say either you made too many incorrect responses or we don't show that. Now for this conditional function, all that needs to happen in here is that it returns true if we do want this thing to happen, or it returns false if we don't. And then you can do whatever you want inside here. You can get the data and all sorts of things to decide what to do. So what we're going to do is get the data from the last set of practice trials and use that to look at the person's proportion correct on those trials and then decide whether they should repeat or not. So I'm going to create a variable called last prac trials. And to do that, I'm going to use a jsPsych function. So it's jsPsych.data.get to get all of the data from the experiment. And then I can filter this data and just get kind of the information I need, which is going to be, like I said, from the last practice trials. And if we go up to the probe object here, so this is where people are actually making their response. This is really the data that I want to get to because this is where we're storing their accuracy. So I want to end up with this data, and I happen to have labeled the inside of the data for this trial. I've just labeled it with trial part probe, and this just makes it a little bit easier to pull it out. So I can, way back down here in our conditional, I can get all of the data and then filter on that so that I'm just grabbing the things that are, sorry, this needs to be an object. So what have I done? There we go. So filter is a function, so it's got the parentheses and then this trial part probe is an object. Okay, so this is going to go and get basically all of the data from the probe responses. And now what I need to do is, we haven't got to this part yet, but at some point we're going to make it possible for people to then be sent back to the instructions and do the practice again. So what I need to make sure of here is that I'm actually just looking at the practice trials from their last round, so that if they've done it twice, I just want the last set. And jsPsych provides a function for doing that. So it's called last, and you can put a number in here, and it'll get the last n things from this data collection. So I could put the number in 3 because we have 3 practice trials, but instead I'm going to use the length of our practice trial array, practice trial info, and then dot length, which right now is 3, but if we change it later on, then that means this will still work. Okay, so now I have our data from the last round of practice trials. So what I want to do is get the number of correct responses and divide that by the total. So I'll create a variable called nCorrect. And what I can do now is, starting with my set of practice trials here, I can then filter that because I just want the ones where accuracy is true. So I'll do another filter function. And then we have an object in here, and it'll return anything in the data where this these key value pairs match. So this will pull out all of the practice trials where accuracy was true. And then I can use another little convenience function here called count, and that just gives me the number of these. So now I have the number correct. The last thing to do is to calculate the proportion correct. So I'll do a variable for this called core, and I'm going to divide nCorrect by, again, just the number of practice trials, so I can use the length of this array. Okay, now I have the proportion correct, so I can just do an if statement, and I can say if prop core is less than some value, let's say 0.6, then I do want to show my message. So then I'm going to return true. And I can do else, return false. So again, return true means yes, show this message. Return false means no, just skip over it. So the last thing to do now is to put this conditional node onto the main timeline. So I'm going to do under here, timeline.push, repeat, prac, conditional. And if I save that and go back to our task here, what I'll do now is just check that it works if I get a few incorrect responses. So I'll need to make at least two incorrect responses, and hopefully we'll see this message.
Flower.
So that one's correct. I'll do two incorrect responses here.
Jam.
So I'll say that's related.
Town.
And I'll say that's unrelated. And hopefully we see, okay, we see a message, you made too many incorrect responses. Now I could do this again, but just for the sake of time, I won't, but just to show that we shouldn't see this if we score at least 2 out of the 3 correct. One thing I forgot to mention, and I've just realized here in the console, we're getting this error, and this is to do with the audio plugin. It's just a bug in the plugin, and it's totally harmless, so you can just ignore it. Okay. It will be fixed at some point. So we've created our repeat practice conditional, and what I want to do now is kind of show you where we're at here in terms of our structure. So now this is where we started, and now what we've done is we've added this thing in yellow here. So this is our conditional node, which contains its own timeline, which is just this one message. And again, this could be whatever you want inside of here. It could be a whole task or whatever. It just has this one message, which we don't know in advance whether this is going to be shown. It depends on the performance in the practice trials. So the next thing we need to add is the actual repetition here, where if the person didn't get enough correct responses in the practice, not only do we want to show this message, we also want to send them back to the instructions and repeat over this again. So they do the instructions and the practice. And then after that, we again need to check their performance. So this is going to go after our conditional. And I'm just going to create a new object called instructions prac loop. And this needs to have a timeline. So you see again, the structure is similar. We have a timeline, and then which is the things we may or may not want to loop over. And then we have, a loop function. And this is going to use the function syntax again. So I'll do an anonymous function like that. Okay, so I want to just quickly point out the difference here, just to remind you of the difference between conditionals and loops. So far we did this conditional, and what happens is when jsPsych gets to this conditional node in your timeline, it'll run this function first, and that determines should I do this thing or not, and then it moves on. For looping, it's a little bit different because this timeline will always execute at least once. So like in this example, the person will always see this trial. And then it's only after this timeline finishes that the loop function runs, and it says, should I run this again? So what this means is, again, so you're always going to do the things in the timeline at least once, and you can repeat over that just some undetermined amount of time. You could do it infinitely if you want to. So this could be useful for you if you are running the sort of task where you don't know in advance how many trials you need to run. You could put your trial procedure in here, and you could just repeat over your trials and just check whether they've met some threshold to stop the task or not. But what we're going to do is repeat over the instructions in practice. And so inside of our timeline, you need the instructions, the practice procedure, which is the whole set of practice trials. And then we also want to check the practice performance. So we're going to add in this repeat prac conditional, which may or may not show that repeat practice message. Okay, so a couple more things we need to do here. This loop function should return true if we do want to go back over this timeline. And if we're done, it should return false. So what we need is this information we already got up here in the conditional function. This is getting all of the practice trials and calculating the accuracy and so on. So we could just repeat all of this again, but I'll just show you another way to do this so you're aware of the options here. One thing we can do is create a global variable, and we can change the value of the global variable inside of this conditional function. And then we can use that value here inside of our loop function. Because remember that what's going to happen is that jsPsych will get here, it'll do instructions, practice, and then repeat conditional, and then it'll check the performance. So it'll do this first, and this is going to say, should they go back through the instructions or not? And then we can use the outcome of this function to determine what happens in the loop, should they repeat or not. Now, I think we mentioned last time that if you create a variable inside of another function, you can't use it in a different function. So it's only available inside of that function. So for that reason, we're going to use a global variable, and I'm just going to write it in at the top out of convention. I'm going to call it repeat prac. And it's going to be a Boolean, and I'm just going to initialize it to be false. So this means we're not going to repeat over the practice or instructions. Then inside of my conditional node, where I'm checking the performance on the last set of trials, inside of this if statement, here I'm saying performance was below threshold, so we can change the value of repeat prac to be true. And then what we also need to do is put it in here where we set it back to be false. And that's because even though we initialize it to false, if it's true and the person repeats through the practice and then they get here again, we need to set it back to false at this point so that they can move on. Okay, so finally now we've done this. We've created a global variable and we're changing it in here. And now what we can do in this loop function is just make it really easy and check the value of that global variable. So scroll up here. So inside of our loop function, we can say if repeat prac is true, then we do want to repeat the loop. So then we just return true. And then else false. So return false. Okay, so a few other changes now we need to make is that we've created this looping node, so we have to put this on the timeline. But the other thing is that now we want to take all of these other things off of the main timeline, because again, this what's going to happen when we get to this point is this timeline is going to execute once. So this will be the first run through these things. So let's add this onto the timeline here. We'll do, timeline.push. And then we'll put in here the instructions prac loop. So the other thing we need to do is take all of this other stuff off of the main timeline. So I'll remove that one. That takes off the conditional. This is all the different parts of the trial. And then we want to take off the instructions. And I think I missed the practice trial procedure too. So those three things. Okay, so we should be ready to go now. This is now the first thing on our main timeline. So we can test this by running the task, and we'll get too many incorrect responses to start with. We should see that message again, and we should get sent back to the instructions. And then if we get enough correct responses, we should be able to continue. So we'll get one correct in this one. I'll say that's unrelated. So I get one correct response. I'll get the other two incorrect.
Flower.
Now I should see the message that I have to repeat the practice. Now I see the instructions again, and I have to go back through, and I'll get two correct here. So I'll say those unrelated.
Flower. Town.
I'll get that one wrong. I think that's okay. So I got two correct responses, which was enough to continue. It looks like maybe I'm going a bit fast. Should we take a little, should we stop here for a second?
maybe it would just be helpful to just review the modifications to the timeline that you just made.
Sure. Yeah. Okay. So starting from here, before this, we had I'll go back to this schematic really quickly. So when we started off, we had the instructions and the practice procedure on the main timeline. Then it went to start task, main procedure, and then an end screen. Now, the first modification we made was to create this repeat practice message, and then we put that side of an conditional. And I'll go back to the code in a second too, if that's what's missing here. But so that was the first modification. So now this message does or doesn't show depending on the performance. But what doesn't happen at this point is we don't get that this loop back to the beginning. That depends on performance. So then what we did was we put these things inside of our practice loop. So this was the last modification we made. We created a timeline with these three things in it: the instructions, practice procedure, and then this conditional. So now what happens is this is on the main timeline. So this is the first thing that happens. Then that hits the instructions, the practice, and then we get to this conditional, which says, was performance good enough or not? And then that kicks off some other things. So we get this message saying, we may or may not get this message saying you need to repeat. And on top of that, that also determines whether the person is going to go back to the instructions or move on, which is the start task. Okay, so I went through that kind of quickly. Let's go back to the code as well here. And remember that this code is also in that finish file, that HTML file, if it would help you to be able to move around and reference different parts. There is a finished version of the task there. So we just created this repeat practice message. But again, we don't want to add this to the main timeline because we don't know whether it should be presented or not. So that went inside of a conditional node. And it was the only thing in that timeline. It's just, should we show this or not? And then this conditional function here just needs to return true if we do want to show the message. Otherwise, it returns false, which means don't show it and just move on. So what we're doing is grabbing all of the data from the last practice round, looking at the proportion correct, and then not only returning true or false in this condition function, but also setting the value of a global variable. And this is what's used in our loop node. So if we go down here and then put in this loop node, and we can just access that, and that determines whether the loop should happen as well. I'm hoping this is becoming a bit clearer. Inside of this loop timeline, we have instructions, the whole practice procedure, and that check, which we need to do every time we run the practice. We also want to check.
So okay. I think there was a follow-up that I think what was confusing for some people was, why do you even have to go back and remove all of those trials?
Oh, okay, right. Right, so let's go back to this here. What happened is when I put these things, I created the instructions, the practice procedure, and the conditional. Originally, those were all on the main timeline. So what happens is jsPsych gets here, it hits this thing and does it. Then it does the practice procedure, which goes off and does this, and it comes back to the conditional. So as soon as we made this loop, this is just a reminder that this loop contains this timeline, which contains this set of events in here. And the way that the loop functions work is they always go through at least once. So this is essentially doing the same thing that we had before. The difference is that jsPsych hits this loop node, and it runs through our nested timeline here, which is instructions, practice, and conditional. And then the way the loop functions work is they wait until the timeline has gone through once and then say, should I do it again or not? So that's why we wanted to take all of these things off the main timeline, because otherwise what would happen is we would do all three things, then we'd get to our loop and they would all do it all again, which is not what we want to happen. Does that
Well, I don't know exactly, but I think that clarifies things.
Hopefully that clears it up. Okay, sorry if this was gone over too fast. So I think we're good on those changes, and hopefully that gives you an idea now about how you can. I mean, these things, like I said, are very flexible, so you can do all sorts of things inside of these conditional timelines and loop timelines, and that can hopefully help you make a more dynamic experiment where you can change the way the experiment actually runs depending on things that are happening in your task that you can't know in advance.
Can I add one quick thing?
Yes.
Which is just that we've only shown examples here where a timeline has either a looping function or a conditional function or timeline variables, but actually you could have all three if you wanted to. So yeah, so you don't use it very often, but if there were a situation where you wanted to have a conditional before you then possibly looped again, then you could do that. The conditional would run before the timeline starts, the loop would check at the end of the timeline, and the timeline variables would be available throughout that entire procedure. But that doesn't come up very often, but just something to be aware of.
Okay, great. I kind of want to see an example of that. Sounds interesting.
Oh, sorry, we did get a quick follow-up about this modification here.
Yeah.
So somebody said, so now there's just a single timeline push the loop. And the answer to that, I'll just say it is yes.
Yeah.
We're just adding on that practice loop, and we've deleted all of the other things because those things are now on the timeline. You can see on line 158 right here. They're in the practice loop, so you can now push them onto the main timeline there.
Yeah. So that's why I thought this diagram might be helpful, because it gets a little confusing. You kind of have to follow things this way, where you're putting this practice loop on the timeline, but that has its own timeline. So you kind of have to look in here to see what's happening. And then it's like, okay, there's instructions practice. And then there's conditional, which also has a timeline. So you can think of it as this thing kicking off this, and then this thing kicking off that.
Yeah.
So, okay.
All right, and one more question before you move on to the next part, which is, could you also use a loop in the main procedure if participants' accuracy is really low in some of the trials?
Absolutely, you could, yeah. So I'm not totally sure what the person is specifically asking, but yeah, you could, sorry, did you say a loop or a conditional?
I think a loop, like if they're responding, I don't know, if accuracy is really low, could you say, hey, wait, maybe you should try harder and go back and do it again or something like that?
Yeah, I mean, you could even do a loop where one way I've used it is to repeat. No, sorry, that's a conditional. Yeah, you could do a loop.
Yeah, I mean, maybe the broad answer is you can put a loop anywhere you want. That, you know, is whatever your design is, you can put a loop in it. And maybe just to connect to something that Josh Hartshorn said last time, you know, one way to maybe encourage good data is to make it annoying to you know, be lazy. So you could imagine using these conditional timelines. You know, if somebody's responding, say, really quickly, like faster than it's reasonable to respond, you can imagine like sticking a conditional timeline that if response time is less than 200 milliseconds, you show a message that says, hey, you're going really fast here, you might want to slow down. And if you have that message stay on the screen for 10 seconds, people will quickly learn that it's not worth it to go too fast. I mean, you got to be careful not to annoy your good participants as well, but it is something that you could do with conditionals and loops. Yeah,
that's actually almost very similar to the example I was going to mention. So I've used conditionals before to tell people that their response is too slow. So in a speeded task, you want to encourage people to be making these responses as quickly as possible. So you could stick a conditional message at the end of your trial procedure. So you do, say, a fixation and then whatever they have to respond to. And then you could do a conditional message that says, please respond faster. And I've done things that way. Yeah, okay. So let's move on. The last thing I want to show you how to do here before we switch back over to Josh is to show a little bit of feedback on the screen. So again, this goes back to one of the things Josh was talking about, which was a great point about trying to create tasks that are a little bit more intrinsically rewarding for the participant. Instead of just saying, please do all of this stuff for me and then say, thanks, you're done. It'd be nice if we could tell them something about themselves that might be interesting, like the music IQ example. So The example we're going to create today is not very exciting. It's just going to show like a summary of the data on the screen. But hopefully what you'll gain from this is just to see how you can access the information that's happened during the experiment, and then use that to change the stimulus, in this case, the end screen that we're going to be changing here. And then you could do all kinds of really cool stuff with this. You could show a participant like the plot of their performance and do lots of neat things. Okay, so we have this end screen, and this always says, thanks, you're done with the task. So what we need to do if we want to put a performance summary on this is to turn this into a function. And I'm going to write this again as an anonymous function like this. And so now what we can do is just change the value of the stimulus parameter based on what's happened during the task. So what I'll do, the basic idea is to create a variable that will store the text that we're going to put on the screen. I'll call it feedback string. And we can modify this in our function. And then at the end of the function, we just need to return it so that it becomes the value of this stimulus parameter. So I'm going to modify it, and then I'm going to return feedback string. And so in between these lines, we can make whatever changes we need to this. And I think I'm just going to put in some text to start with. That's always going to be the same for everybody. It's going to say, thanks, you're done with the experiment. And I'm using double quotes here, so I can put this single quote in the middle as an apostrophe. Okay, so now what we want to do, let's say we want to summarize their performance on different conditions. One thing we could do is grab all of the data from each of the conditions and then do a little bit of processing on it so we could get the mean reaction time and we could get the proportion correct. So this is going to look really similar to what we did in the conditional function, where we're checking the accuracy on the practice trials. It's kind of a similar idea where we first need to collect all of the relevant data together. So I'm going to call that a DOM subset because I'm going to start with the dominant condition. So remember, if you've forgotten at this point, remember I've got some different conditions in here, a dominant related probe word, which I've labeled as DOM, and then a subordinate related, which is labeled as sub. So I'm going to start by getting all of the data with jsPsych.data.get, call that function. And then on the end of that, I can again do a filter like we did before. And I'm again going to do what we did in the practice trials, which is to filter on the trial part, because again, it's the probe part of the trial that has the information I need. So I'm going to do trial part, and then in quotes, probe. So this is going to get all of the probe responses from the whole experiment. But I can add another thing into this filter object. So I can do a comma and add more stuff and filter on more criteria. And what I'm going to filter on is this condition DOM. So I'm going to write in here condition DOM. So now, I'll do single quotes. Now it's going to grab not just all of the probe trials, but all of the probe trials that also match the dominant condition in the data. Okay, so once I have this subset of data to work with, then I can start grabbing the things I need out of it. So I could first, let's start with the mean reaction time. So I'll call it DOM mean RT. And what I need to do is start with this subset of data. And remember that this is going to be all of the data from each of the relevant trials. So it's going to look like a collection of lots of different bits of information. So what I want to do first of all is select the thing from each of these called RT, because it doesn't make sense to take the mean of everything. I need to first select the column called RT. And once I have that, now for each trial, I'm just looking at the reaction time, and I can get the mean of that. One thing I should point out here is if we go back to the documentation, all of these functions that I've been using for data, or you can look at inside the core library API data, and then at the bottom, these are functions for accessing the data and so on. But once you have a data collection, which is when you're subsetting data, you can call you get the list of functions here you can use. So I've been using filter, for example, or count. And then if you select a particular column, which is what we've just done with reaction times, you can then also use these different column methods. And so I've just used the one called mean, but in case you're wondering where to find this stuff. Okay, so we'll go back to the code here. So we've just gotten the mean reaction time. I can also get the, let's do the percent correct. I'll do proportion correct. So we'll do dom prop core. So again, we're starting with the subset of data, the trials that we're interested in summarizing. And then we can filter and just select the trials where accuracy is true. So this is what we did before with the practice trials. And then count those again. So this dot count method. So now we have the number of correct trials in the dominant condition. And we just want to divide that by the total that exists in this subset. So we can do dom subset dot count. So the last thing to do now, we've calculated these 2 bits of information that we want to put on the screen. We can now modify our feedback string. So to do that, we've already initialized this variable, and we can add to the end of it string. There we are, with this plus equals operator. So what this will do is take this variable, add something to the end of it, and then save it back into the same variable. So here we could add in some text that says, maybe we'll put in a label for the condition, so dominant related word pairs. And maybe we'll do a line break with this BR tag. And then we can write in here mean RT. And then what we can do is break up this string by ending it with some quotes and then using the plus sign here. So this will allow us to insert some variables. So we've just got some text, and then we can put in a variable, which in this case is the mean reaction time here. And then we can put some more text on the end, which is the end of the HTML here. And I'm going to add more to this. I'm going to do another line break with the BR tag again. And then maybe I'll do, I'll call it percent correct. Going off the screen here. And again, we'll break up the string with these plus signs. And inside the plus signs here, I'm going to put in our dom prop core value. And then we could just multiply this whole thing by 100 to get the percent. And maybe I'll put a percent symbol after that in the text here. So hopefully you can see what's happening there. Okay, and then another thing I'm going to do, we're almost done. I just, these 2 values here are going to have lots of decimal places. So I'm going to use a JavaScript. JavaScript has a whole bunch of math related functions that start with math. And I'm going to use the one called math.round to round this to an integer. And I'll do the same here for the math. Round. So that will round off those 2 values so that they're integers. So hopefully you can see that. Sorry, it was going off the screen there.
Just quick clarification question. Yeah. So somebody's wondering about the practice trials. Will they be included in this, or are they filtered?
Oh, great question. Yes, I forgot to mention this. So you'll notice I'm filtering on the trial part, which is probe, and that's true for all of the trials, both the practice and the main task. And then I'm also filtering on the condition. And I just happened to know, and I didn't point this out, that in my practice trial information, I did give these conditions, but I made sure that they were different. So now the fact that I'm filtering on both of these things means that I'm only going to end up with the main trials because those are the only ones that have been labeled with this particular condition. Okay. So hopefully this will work. We're not going to run through this for the sake of time. We're just going to assume that it works, because there's just one more thing I want to show you, and then we will actually test this. So you'll notice that if I want to repeat this for my other conditions, I would be doing some copy pasting here and repeating these lines of code, but changing little things to get the appropriate condition. So sometimes when you notice that you need to do that sort of thing, it's a good idea to put that into a function. And that way, if you want to change anything, you're only having to change it in one place and you're not having to repeat yourself so many times. So I think just before this end screen, I'll just make a function here. And I'll call it generate feedback string. And I want it to do all of this stuff. So it's going to do the subsetting, and then it's going to calculate the mean reaction time, proportion correct, and it's actually going to give me back this whole string. So I've cut those 4 lines. I'm going to paste them into this function. Okay, now we do need an argument to this function because we need to say which condition it is that we want to summarize. So we can do that by adding the argument that we want to pass in here, and we just give it whatever name we want. I'll just call it cond. So when we call this function, we're going to pass in the condition, which might be dominant in quotes, and then inside the function, that becomes the cond variable. So what I'm going to do now is change the names of these variables so that they're more general, because they're no longer specific to my dominant condition. Change this in a few places here. This just becomes subset instead of dom subset. And then just mean RT and mean prop core. Okay, so the other thing now we need to do is a couple things. Here we're passing in the condition that we want to filter on. So instead of having dom here, we're going to use the value of that variable. So we'll write in here cond. Another thing we're doing is in this line here, we were adding this text onto a variable that was already created. In this case now, we're going to be calling this function, and we just want to return this from the function. So we're going to write in here return, and it's going to return this whole string. And then we can call the function inside here and then use the value to modify our feedback string. Okay, one last change we're going to make is to notice here I've given my condition a title, and that's going to be another thing that changes depending on which condition I'm filtering on. So I'm going to turn that into another argument. Right now I'm passing in the cond, which is the abbreviated condition that has to match one of these. So I can add a comma and then add in another argument called cond title. And then I can just take the value of that and put that in here. And so we're going to do the same trick again where we can break up the string and use some plus signs to join the different things together. And we're going to put this cond title right in here. Okay, so then what's going to happen is inside of our end screen, we have this function that's going to generate our stimulus. We're still going to create this feedback string like this, and then we're going to modify it like I said we would before with this feedback string plus equals. But now what we can do is use this function, and we can give it the condition and we can give it the title. And it's going to return the text that we want to add onto our feedback string. So I'm going to call the function generate feedback string, and I'll call it with the dom condition. And then I'll also give it a title. So again, in quotes, I'll call it dominant related word pairs. And now what I can do is just repeat this line, and it will keep modifying my feedback string with other things. So I'll do the same for subordinate here, and I'll rename the title to subordinate related word pairs. And the abbreviation here is sub. And then for my filler trials, I've labeled these as FIL. So I'll just call this unrelated. These are all my unrelated trials. So hopefully what you can take away from this is this idea that sometimes you can create a function that you can then use as kind of a helper function do other things. And that helps to kind of reduce the amount of copy pasting stuff you're doing. Okay, so now we're going to run through one last time, and then we'll check that this works and we can pass over to Josh then. So we'll get all the practice trials correct.
Flower. Town. Jam.
And then I'll make a few errors in the main task.
Cheese.
So I'll say that was related.
Axe. Straw. Calf.
I'll say that's unrelated.
Toast. Fruit. Knee. Mouse. Zoo. Pen. Crowd.
Okay, how are we doing? So we have, these are this is the output of that function that I called 3 times. And it's given me the summary for my dominant, my subordinate, and my unrelated conditions from the main task. You can see I've got different mean reaction times for each of those. And I did make 2 errors. So one of the errors was in the subordinate condition. And there's only 3 trials, so now my accuracy is 67%. And I also got one of the filler trials wrong, and there's 6 trials. So that's why that's reduced there. So I think we're done. Maybe we could take questions or just switch over to the next section.
At the moment, I don't see any questions in my queue. There might be ones that have been asked, but the rest of the team has decided that maybe those are best answered either in chat or on Thursday. So just a reminder that we do have our Thursday Q&A. That's from 1 to 5 Eastern time on the jsPsych discussion forums, and that's linked to on our website at movingresearchonline.info. Yep, I'm just getting confirmation that there's no questions right now.
Great.
The next thing that we're going to be doing is I'm going to be walking through creating a new plugin when you might want to do that and how you would do it. I think we're planning to take like maybe just a short break here, although if there's nothing to do, no questions to answer, we're not going to have much to talk about during that break. But if maybe I'll try to pause for about 2 to 3 minutes right now before I really jump into the plugin code. And if you have a question right now that we didn't get to talk to, this would be a great time to throw it up in the chat. And if any come in, we'll take the next 3 minutes to answer those. And we'll get started like 2:35 or so for the plugin creation. Okay, so we just got a question. So what are some of the timing functions that are available for between trial blanking? So great question. So there's one, let me switch over. Oh, you know what? I don't have a window open yet. Let me create one. I'm going to open up the documentation to show you where to find this. Okay. So it would be hard to find if you didn't know where to look, unfortunately. But in the plugins, there are some parameters that are available in all plugins, and some of those we've seen. So we've seen the onFinish function. You can always use an onFinish function. There's also the data property, which is universal to all plugins. Even if you create a new plugin, like we're about to do, these things exist no matter what. So even in this brand new plugin, these functions will be available automatically, even if we don't have to program them explicitly when we create a plugin. And then there's these 3 events that we can use. But to answer the question, there's this post-trial gap parameter. And this sets the time between the current trial and the next trial. By default, it's null so that the trials immediately advance to one another. But if you wanted, say, a 500 millisecond blank screen, you would just set that to 500. And if you were running an experiment where you knew that you wanted all of the trials to have a gap, you can actually set you can set a default ITI parameter in the jsPsych.init method. So I'll just show that. So there's lots of things in jsPsych init that we haven't talked about, but one of them is the default ITI. So by default, this is 0. But if you wanted by default to have 200 milliseconds between every trial, you could set that to 200. All right. So don't think there are any other questions outstanding at the moment. So I'm just going to get set up here quickly to talk about plugin creation. All right, so just to give an overview of what I'm going to be doing here, I am going to create a new plugin from scratch, and we should be able to get through it in about 45 minutes. So we should be still on track to end and have a little bit of time for questions, either along the way or at the end. And if you go to the folder that you downloaded, there is a folder in there, Day 3 plugin development. And this contains the final code that we'll get to. And if you open up the HTML, the experiment here, this will demo what we're going to be doing. And I'll just show that right now. So what we're going to be doing here is we're going to create a self-paced reading example with a moving window. So the plugin allows you to press a key, and that advances to the next word. And the plugin records 2 pieces of data, what the words were that were on the screen and the reaction time to each word individually. So you can see here that I waited for 11 seconds or so before responding to the first one, but then it was just a few hundred milliseconds for the last 4 words. So this is actually, this is an experiment that if you wanted to, you could actually create it without a new plugin. You could, for example, you could patch together 5 different HTML keyboard response trials with no gap between them. And you could just have your stimulus be this for the first trial, and this for the second, and this for the third, and this for the fourth and the fifth. And then you would have the same data, but it would just be spread out over 5 trials. So this just brings me to point out that plugins are a means of abstraction. They're a way to, they're a way to implement what you need participants to be able to do. So sometimes there are cases where you need to create a plugin because there's no way to do what you want to do with the existing plugins. But other times it's useful to create a plugin even when the existing plugins would be able to do it, because it's a way to abstract the problem and make it much simpler to write new experiment code, much simpler to construct your timeline. So rather than like putting together 5 trials worth of HTML keyboard response for this single demonstration, instead, what we're going to be able to do is create a single trial that just has a list of words, and that will take care of everything for us. So sometimes it is useful to use what's there, and sometimes it's useful to be able to jump in and create a new plugin. So I am not going to be working directly with the code that's in that folder. That code is there as a reference that you can look at later on. What I've done is I've created a different folder where I've downloaded the jsPsych library. And I also have an example experiment file already created here. But I don't have any custom plugin code yet. So let me just get this folder open here. Okay. So right now in this folder, I've got my demo HTML file, and that looks like this. So I've already created the experiment that I want to be able to run, which is the one that you just saw. So I've loaded in a plugin that doesn't actually exist yet, which we'll create in a second. And then I create a single trial with it called, so this plugin is going to be called Moving Window, and it's just going to take a list of words. And then we're going to add that trial to the timeline, and we're going to run that experiment with the data displaying at the end, just so we can see what the plugin is recording. Okay, so now we need to create the plugin file. So we've got the experiment, and once we have the plugin, we'll be able to run it. So inside the plugins folder, maybe I'll show this in Explorer, is if you open the jsPsych file and you open the plugins folder, you get the list of all the included plugins. And one thing you could do is, you could take a plugin that's pretty close, like the HTML keyboard response, and you could copy it and you could modify it to suit your purposes. Another thing you can do is you can, inside this template folder, there's a file called jsPsych plugin template. And you could copy this file, and you could create a new plugin by using this as your base. So that's what I'm going to do. I'm just going to rename this right away. I'm going to put it in the root directory of my project. I'm going to call it -moving window. You might be wondering why I didn't put this in the plugins folder. It doesn't actually matter where you put plugin files. And when I create plugins that aren't sort of part of the official jsPsych release, when I'm doing an experiment, I usually just put those in the root directory or in like a separate folder like custom plugins. That's just my personal preference. If you wanted to stick it in the plugins folder, you could do that as well. So I've got that file here. I'm going to close this folder now. And I've loaded it into my experiment already. It's expected to be in that location. So let's take a look at what's inside that plugin file. So here's the template. And inside the template, there are really two critical things. There's a section called plugin.info. And this contains some information about the plugin, like the name of the plugin and a list of parameters that the plugin allows you to use, the things that you would specify, like stimulus or choices or the keys that you can press and things like that. And then there's a second thing, which is a function, and this function is plugin.trial. So this is a function here, and this function is what runs when you call the plugin in your timeline. So essentially, you can think of it as like jsPsych determines what the next trial is in your experiment based on whether you're using conditional or looping or just straight linear timelines. It figures out what the next trial is, and then it takes those parameters that you've specified for that trial, and it calls the appropriate plugin.trial method, the one that's associated with the plugin, and then the code that's in here runs. And the only thing that you're actually required to do inside this plugin.trial method is to call jsPsych.finishTrial at some point. And that's the command that lets jsPsych know that this plugin is done with its task, and it's time to move on to the next part of the experiment. And when you call jsPsych.finishTrial, you can pass in any of the data that are generated on that trial. So I've created in the template file, there's a sort of a default object called trial data that's created with sort of a generic parameter name, parameter value, but you could specify whatever you wanted in here. And then in terms of the arguments that are passed to this plugin, display element is the element on the page that the jsPsych experiment is running in. So far in all the examples we've looked at in this workshop, the jsPsych experiment has taken up the entire page on the screen. It's running the body element by default. But actually, you could, in the jsPsych.init method, you can specify if you want JSPsych to run in a subset of the page, you could do that. Now, in a case where you might want to be able to do this is like, imagine that you are generating some instructional materials, say because you've had to move your teaching online, not just your research online, and you want to maybe give a practice experiment where students are, completing a lexical decision task. But you also want to sort of embed some text around that, like maybe a narrative about the what they should be expecting to see. And then they have a few demo trials. Well, you could create a website where you had kind of like a textbook with a little window embedded in it that was actually running a jsPsych experiment. So that's what this display element is doing. It's giving you the access to the element on the page that you're allowed to or encouraged to modify when you're running this plugin code. And then the second argument here is called trial. And this contains all of the parameters for the trial. So all the things that we specify. So these things here, like words, this would be included in that trial object. Basically, the function here gets a copy of whatever we've declared on our timeline. And then it uses that to control the display of what the plugin is doing or the plugin's behavior. So let's go ahead. Let's put together this plugin sort of piece by piece. We'll go step by step and hopefully illuminate how plugins work along the way. So the first thing I'm going to do is actually change the name right here and here, because this name right here is the name that determines what you have to specify here in the type. So this must match. So this plugin name here should be moving window. And I'll put the same thing here. And then for our plugin, for this one, there's lots of parameters that we could specify, but we're going to just try to keep it simple. We're going to have two. So one we've seen already is words. This is going to be the set of words that we want to display on the screen. And this type parameter tells jsPsych what kind of variable it is. Is it a Boolean? Is it an integer? Is it a string? Is it a function? And actually, it's not that important that this be correct. The reason that this type parameter is in here is because we've been working on a graphical experiment builder for jsPsych that is not done. And we need this information in order to make that graphical experiment builder work. But for when you're just coding with jsPsych, the only time that this information is important is if this is a function. So if it has to be a function, then we need to know that. But otherwise, you actually don't need to specify it. But it's just good practice to have it in there. And then this second option here is the default value. So if you don't want people to have to specify a value for this parameter, then you can give a default value here. And that default value can, of course, be overwritten by the programmer. In this case, we want the default value to be undefined because it doesn't really make sense to provide a default value for the words. We need the researcher to specify what words they want to show. So if your default value is undefined, then and the researcher or the programmer doesn't declare a value for that plugin, then jsPsych will throw an error message that says, hey, I was expecting a value for this parameter. Okay, the second parameter that we're going to use, we're going to call key. And this is going to be a key code. It's going to be that two-digit that digit-based representation of keys on a keyboard. And I'm going to use 32, which is the space bar. So essentially, if you don't specify what key subjects are using to advance, we're going to default to using the space bar to advance. Okay, now we've got our parameters set up. So we're going to have words and key. Now we need to actually do something in the trial method so that we can show something on the screen. So let's display the words on the screen. That's a good first step here. So I'm going to go down here, and I'm going to use display element. And remember, this is the element on the page that we're modifying. And by the way, it's kind of unavoidable right now that we're going to be dealing with some features of JavaScript and HTML and CSS that we probably haven't fully introduced to you if this workshop is your first exposure to these languages. So hopefully conceptually what's happening here makes sense. And then you can always go back and look up the specific methods. I'll do my best to talk about them as I implement them, but I apologize if this goes a little quickly on that front. So one of the ways that we can modify the display element, which is just an HTML element that's on the page, is we can set the HTML. We can say inner HTML, the HTML that's inside that element, and we can set it equal to a value. So here I'm going to set it equal to a paragraph, and I'm going to use trial.words. And I'm going to close my paragraph. So if you think back to day one of this workshop, we talked about the interplay between JavaScript, HTML, and CSS. And this is an illustration of that. What JavaScript is allowing us to do here is not really like directly control the display. We're not using JavaScript to render things on the screen. What we're using JavaScript to do is actually to modify the HTML of the page. And then the browser is taking that HTML and re-rendering it so that the display is updated as a result. Okay, so we've now modified the display here, and we've shown trial.words. Maybe the other thing we could do here is we could record the words in the data. So I'll say words is trial.words. And this is actually a valid plugin at this point because we've called finish trial. So as long as we call finish trial, we're good, and we've even passed in some of the data. So let's just see what happens if we run this. So I'm going to open this up, and I'm going to go up here. I'm going to refresh this, but you're not going to be able to tell that I refreshed it, other than the fact that this time elapsed variable has changed. And the reason that this is happening, that we're not seeing the words on the screen, is that what happened in our plugin is that we changed the display, but then the trial immediately ended. And in our experiment that we've set up, when the trial ends, we have this onFinish method that displays the data. So basically what's happening is that the trial is happening so fast that the browser never even bothers to render the words because it's too quick. And then by the time the experiment is over, we're ready to see the data. So what we need to do is have some kind of pause in here. We need to wait for a response from the user. So let's go ahead and wait for a keyboard response. Now, you could sort of use vanilla JavaScript, like standard built-in JavaScript, to create a keyboard listener. If you're a familiar JavaScript programmer, right? Anything you wanted to do in JavaScript, you could just do it right here if you wanted to. But jsPsych also has some built-in functions, and they are part of. Let me see if I can get the documentation up quickly. They're part of this plugin API module. And this contains some helper functions for when you're writing a plugin. And the one that we're going to be interested in is a method called getKeyboardResponse. And basically, this is a function that does some fairly sophisticated things to help us get keyboard responses in the way that we would want to get them in the context of an experiment. And there's a lot of options that can be passed in here as well. And then here's an example. So we can sort of see, like, here's the method being called, and there's some other stuff happening here. I'm not actually going to walk through this example right here. I'm going to show you in a different context, which is I'm going to show you in the context of another plugin. So one thing that's helpful when you're developing plugins is that, well, there's a whole library of plugins that you can reference. So I'm going to open up the HTML keyboard response plugin. And you'll see that there's obviously a lot more code here because it's a plugin with more parameters, but it's got the same structure. It's got a plugin.info. It's got a handful of parameters, 6 parameters or so here. And then we're doing the same kind of thing, right? We're modifying the display by setting the inner HTML to some string that uses a parameter from the trial. And there's a lot of other things happening here. Don't worry about those at the moment because we'll do similar things in our other plugin. But what I want to show here is that we're using this getKeyboardResponse method here. So I'm actually going to go ahead and just copy this and move it into our plugin and put it right after we change the display. And okay, now what's going on inside this getKeyboardResponse method? Well, there's a whole bunch of parameters that we've passed here. What are these parameters doing? The first parameter is the most important. It's called a callback function. And what this is it's a function that we want to execute when the subject presses a key. So basically, what are we going to do when the subject presses a key? We're going to call this after response method here. And we'll actually create an after response function in a second. But first, I want to talk about the other things here. The second argument is an array that specifies all of the keys that are allowed to be pressed. And any keys that aren't in this array will be ignored by default. So in this case, we have only one key that we want to be a valid key. So what we can do is we can put an array here and we can say trial.key. And this will allow us to only use the key that's specified as part of the parameters for this plugin. Okay, the third argument is the method for measuring the response time. So currently in version 6.1.0, there are two different methods for measuring response time. In most cases, you'll want to use the performance method. And the other method, I believe, is called audio. And this is a method that you may want to use if you are trying to synchronize response times to the onset of audio files. There's a different clock that JavaScript provides if you're doing that web audio API method that, that Becky mentioned briefly when she was talking about audio. I'm not going to dwell on this right now, but if you wanted to see that in action, you could open up the audio plugins and you would be able to see that audio RT method available. Okay, last two things. Persist is true or false. This just means after we get a response, do we listen for another one? So do we want one response or more than one response? One thing to mention here is that if you get more than one response, the RTs are cumulative. So they're from the initialization of the listener. So if you say true here and you get lots of responses, the response times will all be, they'll be strictly increasing because they'll always be adding on to the end of the previous one. And then finally, this is an important one too, this allow held key. If you don't have this, if you have this set to true, then what will happen is if somebody presses a key, like say the space bar in our plugin, and then in the next trial, there's another response for a space bar. Well, if somebody's holding down that key, the keyboard response listener in JavaScript will by default register this multiple times. So basically, as you're holding down the key, JavaScript will keep saying spacebar, 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 and it'll just repeat that over and over again. And so one of the things that this get keyboard response method does is it has some logic in the back that checks to see if the key was already held down when the keyboard listener was created. So basically, if somebody's holding down the spacebar and we create this listener and allow held key is false, then they'll have to lift the spacebar up and press it down again before we will get a response. Okay, so this is that method. And as I mentioned before, the next thing that we need to do is create this method for what do we do after we get a response. So I'm going to write a function called after response. And what we do in here is we can process the response that we got. So one thing that we'll want to do is measure the response time. So I'm going to go ahead and, since we're going to get multiple response times over the course of this plugin, I'm going to go ahead and create an array up here called RT. And when we get a response, I'm going to add the latest response onto the RT array. So I'm going to do, and the way that you do this is there's an argument that gets passed called, you can call it whatever you want, but I'll call it response info. And we can say rt.push to add on to the end of the array, response info.rt. And the other thing that's in response info is the key value that was pressed. So, excuse me, which key was pressed by the user is in there as well. Okay, and then after we record the response, at the moment we're showing all the words on the screen at the same time. So let's go ahead and call another function that we haven't created yet called end trial. So we'll record the response time and then we'll end the trial. And to end the trial, I'm just going to create a function here called end trial. And I'm going to stick my finish trial method in right there. Okay. And the final thing that I'm going to do at this stage before I demo this one more time is we need to take this array that we've created here and we need to actually add it on to the trial data. So the way that I'm going to do that is inside the end trial method. Once we've got all the response times, I'm going to do trial data. I'm going to create a new object or a new value on the trial data called RT. And I'm going to set that equal to, well, one thing you could do is you could set it equal to RT. But that's actually not recommended in jsPsych because RT is an array. And in plugins, we try to make sure that all of the data are primitive types. So strings and numbers and Booleans and things like that, not arrays and not objects. So if you have an array or an object and you need to save it in the data, what we recommend doing is using the stringify method from JSON to convert your array to a string. So this will just take your array and it will convert it to a JSON string and we'll store that in the data. Okay, so I'm going to go and open the plugin again. So now notice that the text is on the screen and it doesn't immediately get replaced by the data. So if I press the space bar, then I can also see some data that's been recorded. I get the dog chased the car and I get the response time. So it took me 10 seconds to talk about that before I hit the space bar. So we're getting there. We've got a good chunk of what we want to do. In fact, we've kind of created like a very simple version of the HTML keyboard response plugin. The HTML keyboard response plugin has many more parameters, which is why it's a little bit longer. But we've got some, we've got this words parameter, which can render some HTML on the screen. And we've got a key that we can respond to it and measure the response time. So we've already sort of created a workhorse jsPsych plugin in just 15, 20 minutes or so. So now what we want to be able to do is actually show this stimulus in the way that we need for this moving window task. So to do that, I'm going to write a function that is going to help us take this string of words and convert it into the moving window. So I'm going to do create moving window. And I need to know two things when I create the moving window. I need to know what the words are. So I'm going to have a words parameter. And I need to know which position I'm at in the list of words so that I know which word to leave alone and which ones to blank out. So let me just pull up, make sure that I'm doing this in a similar way to what I did in the demo file so that it matches later on. Okay, so the first thing that we need to do is this list of words is a string right now, right? It's the dog chased the car. And we need to figure out how many words there are and which one to blank out. So what we're going to do is we're going to convert that string into an array where every element of the array is a single word in the sentence. So I'm going to do create a variable called word list. And I'm going to use a method in JavaScript called split. And split is a method that you can use on a string. And you can pass in a character or a string of characters to split the string by, and it'll just divide up the string. So it'll take something like the dog chased the car, and it'll turn it into an array. It'd be like this: the dog, etc. So that's what words.split is doing. Once we've got this array of words, we need to convert all of the words in here that are not at the current position to dashes to sort of remove them. So I'm going to create a new variable called stimulus, and I'm going to take my word list, and I'm going to use a function called map. Map is a function that allows you to apply a function to every element in an array. So if you're coming from like R, then it's very similar to like an apply function in R, sapply or lapply or something like that. If you're new to programming, this will seem a little bit weird, but hopefully I can make it a little clear. So what we're going to do is we're going to create an anonymous function, and that function is going to take in a word, and it's also going to take in the current index in the array. And this is how the map function works. The first argument that it passes is the value in the array, like and the second argument that it passes is the index of that element, like 0, 1, 2, 3, 4. So inside that function, what I'm going to do is I'm going to check if the index is equal to this position argument. So if index is the same as position, then I'm just going to return the word, because I don't want to modify it. If we're trying to get the 0 position word and everything else is blank, we just want to leave that word alone. But if they're not equal to each other, then I want to return a set of dashes where it matches the length of the word. And one way to do that is to create a dash and then use the repeat method to repeat it some number of times. And how many times do we need to repeat it? Word.length will do the trick. So for the, we would repeat a dash 3 times because the has a length of 3. Okay, I have too many parenthesis things here. So that's my else, so I should delete that. Okay. So I think that will do the trick. So what we have now at the end of running this is, say it was position 0, we'll have something that looks like, we'll have an array, but we'll have like dog will be blanked out and Chase would be blanked out and so on. Now we need to do is take this array and convert it back into a string so that when we add it down here, it's just a string of a sentence that's on the page. So the JavaScript method to do that is called join. And this allows us to join an array join all the elements of an array back into a single string. And we can specify the character that we want to use to space them out. So you can think of it as like the opposite of split. Split takes a list of words and converts it to an array and separates on this. Join takes an array, converts it back to a string, and puts this character in between. So we should get the blank, blank, blank as our final output here. Okay, and then the last thing we need to do here is we've created our stimulus. That's good. We just need to return it so that when we finish this function, we have that stimulus available to us. Okay, and then right here, we would need to say create moving window. So instead of just showing trial.words, we need to actually use this function that we created, and we need to show the moving window at sort of the current position. So we don't have a current position yet, but I'll put a variable in that says, let's say current word. And up here at the start of my plugin, maybe I'll make a variable current word equals 0. So that'll be where we start. And then this will render on the screen. So, okay, what's going to happen now? Let's test this out. So we get the blank, 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 blank. If I hit spacebar, the trial ends because we haven't put in any logic yet to actually go to the next stimulus in the sequence. But that's the last thing we need to do here. So we're going to want to do this part of our code where we show the stimulus and get a response. We're going to want to do that once for every word in the sequence. So I'm going to take this bit of code. I'm going to wrap it in a function. I'm going to wrap it in a function called show stimulus. And I'm going to just move this inside of here. So what this will do now is actually nothing would happen if we ran the code right now, because we have to call this. So we've created this function to show the stimulus, and then right before we're done, we'll do show stimulus to start the experiment. Okay, so that should look identical to what we just did. I'll just show that again. So even though we've changed the code, this looks exactly the same because all we've done is wrap things in a function and call it again. Now what we need to do is after we get a response inside this after response method, we need to move on to the next item in the list of words. So we can do current word. We could do current word ++ to add 1, or we could say current word equals current word +1 to be extra clear. And then we could say if current word equals the number of words, so equals trial.words, Somehow we need to figure out how many words there are, and we've actually already figured that out. We use this words.split, so we could do trial.words.split and .length. So again, this is just taking the string of words that we have, splitting it by the spaces, and then counting how many elements are in the array. So if we've reached the end of the array, then we will end the trial. But if we haven't reached the end of the array, then we will show the next stimulus on the screen. And because we're updating this current word variable, and because that variable is it's not really a global variable, but it's a variable that exists inside of the plugin.trial method. It's outside the scope of just this function. You can use it, you can change it here and access it here as well. Okay, so I think that this will show the entire string now. Let me check that. So we have the dog chased the car, and we get all 5 response times here. So just maybe I'll recap really quickly the structure of this before I do the last few touches on this plugin. So we've got this function that helps us generate new stimuli. We have a function that shows a stimulus on the screen and gets a response, creates a new keyboard listener for that response. And when that response happens, we then call this after response method, which adds the response time to our data, advances to the next word, and checks whether we should end the trial or show the next stimulus. And if we end the trial, then we modify that response time array to add it to our data, and we call the finish trial method to end the plugin. The other thing that's sort of a good idea in these end trial methods is to do like some cleanup. So right now, just to maybe illustrate this, I'm gonna comment out in my experiment here, my demo experiment, where I've got the timeline and I'm running the jsPsych experiment. I'm going to comment out this onFinish display data just to show you what happens at the end of the trial right now. So I'm going to do the dog chased the car, and I've hit spacebar. So I've pressed that key multiple times. The experiment has actually ended, but the display still has the stimulus on it. And that's because the plugin never cleaned up. It never got rid of the display. In jsPsych, we allow plugins to make permanent changes to the display. So you're not required to clean up what the plugin has done. But in general, it's a good idea unless there's a reason to make a permanent change to the display. So what I'm going to do is I'm going to go in here, and I'm going to say display element dot inner HTML equals blank string. So I'm just going to remove all the HTML from the display element. And I'm going to go back to my demo. And if I click the space bar now, we don't see the data, but the plugin has ended, the experiment has ended, and it cleared itself off of the screen. If you're familiar with JavaScript development, and one of the things that you can do inside plugins is set up event listeners. One thing that's pretty critical to do if you've set up an event listener inside a plugin is you need to make sure that that event listener is destroyed or removed inside an end trial method before you clear it. Otherwise, you get really weird behavior in your code. I don't want to dwell on that too much because I don't want to lose people who are unfamiliar with event listeners, but just something to be aware of and why this cleanup process is pretty important. Okay, the last thing that I just want to show here with this plugin to make it a little more useful is that you might have noticed that in the string right now, the width of the string kind of changes. So it's not that nice, clean, where the letters sort of appear exactly where the blanks were. And that's because we're not using a monospaced font here. We're using a variable width font where the dashes are smaller than the letters. So we can fix that by using some CSS. So right here, we could add some style information to, this is where we're rendering the stimulus onto the screen. we could add some CSS right to the display, and we could say that we want the font family here to be a monospace font. And any monospace font will do. So a monospace font is a font where the width of the characters are all the same. So like ones that you might be familiar with are like Courier or Courier New, those sort of typewriter looking fonts. And that will ensure that the characters are all in sort of spaced out the same way, and it will make it seem like the words are sort of appearing where they're supposed to appear. And we could do other things too, like we could set the font size to be, say, I don't know, 28 pixels here. And this could also be a parameter, right? You could make another parameter for your plugin. In your plugin.info, you could add font size as a parameter. So you could do, right, font size. And this would be, say, we would do like an int. We could say the default is 30 pixels. And then once we have that parameter available, we can, instead of just having this hard-coded value here, we can do that thing Becky was doing where we sort of add things together in the string, and we can just do trial dot font size. And because I've specified a default value of 30, when we launch the experiment again, that it will actually be in a 30 pixel font. And because it's a parameter, if I go back to my demo experiment where I've created this timeline, I could specify font size here. So I could say use 80 pixel font. And then we get a giant string. So hopefully what this shows you is that creating a plugin is assuming that you are comfortable with a little bit of JavaScript. And even if you're not, hopefully there's enough examples and things to work off of in the other plugin files that you can use those as a starting point. And this hopefully demonstrates that plugins are both extremely flexible and also not too terribly difficult to start putting together. If there, I don't know, do we have questions, Becky? I think this is about the end of what I wanted to demo with this particular plugin file.
Yeah, great. I'm not seeing any questions.
Okay.
Wait and see if a few more pop up. Should we just wait a second, or if you have anything else you want to show?
Yeah, maybe while we let questions come in, if there are any questions, maybe what I'll do is show you another plugin file and just show you that another thing that you can do if you are, if there's a plugin that's really close to what you want to be able to do, but it's like something's just not quite right. You can always modify the plugin files, right? You get your own copy of the plugin file whenever you download the library, and you can just go in and change those if they're not doing exactly what you need to do. So I'm gonna have to modify my experiment here just to be able to show this quick. But let me load in maybe let's do the button response one. HTML button response JS. I'm just gonna modify this. So this will be the stimulus. Let's do choices, grammatical. What is it? Ungrammatical? I don't know. I don't know the right word. Let's put a prompt on the screen. And choose the right type of sentence. Kind of I don't know, I'm shoehorning an experiment here, but let's just show this quick. Oh, no, I messed up. Right, wait. I must have a typo. Oh, it's because it's not in the right folder. JSPsych plugins. Okay. Button. All right. Okay, so This is kind of the default behavior for the HTML button response plugin. So it shows the stimulus, it shows the buttons right below the stimulus, and then it shows the prompt below that. What if you wanted the prompt to come above the buttons? Now, you could do that through some CSS. You could, I don't think we have time to show this because it would take a while to set it up. But without modifying the plugin file, if you wrote the right kind of CSS, remember CSS controls everything about where the elements display on the page. You could do some trickery to kind of move this so that it was above that by specifying positions on the page. But if you really just wanted this to be above the buttons, a much simpler thing to do might be to open up the button response plugin, to go down to that plugin.trial method, and let's see if we can parse what's going on here. It's a little tricky because there's all this button stuff, but there's some minimal comments that'll help. So inside the plugin.trial, we're creating an HTML string where we've got the stimulus. So we're adding the stimulus here. And then there's a bunch of code here that is adding to that HTML string. So notice we're using that plus equals syntax to add more HTML onto this string. And we're doing some stuff in here that allows you to customize the buttons, etc. And then notice that after that, there's this trial.prompt where we add the prompt, if there is one, onto the end of the string. Well, if you wanted the prompt to come before the buttons, you could just take this code in the plugin file, and you could literally just move it right above the buttons. And you could save that. And that's the same copy of the plugin that I'm using. And so I'll refresh. And now we get the stimulus, the prompt, and the buttons display below that. And you could, if you're not happy with the default CSS here, like everything's pretty close together, I mean, you could modify that by changing the CSS in the experiment, right? You could say, oh, I want this to be a paragraph, and I want to add some style to do that. But you could also do that directly in the plugin file if you thought it made sense to modify it there. All right, any questions that have appeared?
Great, thank you. We've had a few that I think maybe we
Okay.
The most recent one was somebody's asking why plugins are useful and advisable, and is data output organization part of that? So I wonder if you could just remind people why we have plugins.
Yeah, okay. So plugins are necessary. So it's kind of, maybe the name is maybe I chose a poor name because plugin usually implies like additional features. But in jsPsych, all of the code that runs a task on the screen, anything that's displaying on the screen, that's part of a plugin file. So anytime you want to say, all of the experiments we've been setting up, anytime you say, oh, it's an HTML button response trial, or it's a HTML keyboard or an audio keyboard, all of those are plugins. This is just the design of the jsPsych library. And there's a rationale here, which is that when we run experiments as researchers, we often are running the same kind of experiment, the same kinds of tasks repeatedly. We don't just develop a task once and then move on to the next thing. No, I mean, we develop tasks like a moving window self-paced reading task, and then we run it with a bunch of different kinds of stimuli and a bunch of different kinds of parameters. And plugins are a way to sort of capture that practice of doing scientific research and get the right level of abstraction. So this allows you to, if you're developing a task like, self-paced reading, you can write the code, do that task once with some parameterization. And then when you develop your next experiment, you're not rewriting that code, you're just using the plugin file. It also lets you share your tasks more easily. I think there's like 40 or so plugins that come with jsPsych right now. And many of those were not developed by me as the developer of jsPsych, but they were contributed by members of the community who developed plugins that we thought were sort of generally useful enough to include it in the distribution of jsPsych. And you can also find plugins that exist outside of the jsPsych library. So there are people who have published papers that are, here's a plugin for jsPsych, and that you can go download that and just add it in to your library. So it's really just a method of abstraction, but it's also because of the design of the library, it's essential. Anytime you want to do something on the screen, it's in a plugin file.
Great, thank you. And that actually also relates to one of our earlier questions about where people might be able to find other plugins that people have written, if other researchers are writing their own custom plugins.
Yeah, that's a great question. So we're in the process right now, and sort of this has been put on the back burner, but we're trying to create a repository on GitHub that is part of the jsPsych GitHub community organization that anybody can add a plugin to, where you can just sort of say like, hey, I've got a plugin, I'm going to add it to this repository so that other people can find it more easily. If you're, I think the other thing to do right now is if you're looking for plugins that haven't been created, that aren't part of the jsPsych distribution, Googling for some of that will definitely give you some hits. Unfortunately, I think there's a lot of plugins that people have created, and I'm guilty of this myself. I've created plugins sort of for an experiment, but I don't like document them thoroughly because they're for myself. So I have code, and if somebody on the jsPsych forum says, hey, I'm thinking about doing this thing, and it's similar to a task that somebody's developed, I've chimed in before and said, hey, I wrote a plugin that's pretty close to this. Here's the plugin code, and you could start here and modify it. So I would say asking on that discussion board is a good step, in addition to the usual search techniques that you might use. And just to reiterate what I said at the start of that answer, we are working on sort of a more systematic way of doing this, but we've got to get the infrastructure in place to make that sustainable.
Absolutely, yeah. So the discussion board is a great place to ask for feedback and say, has anyone else done this? And then there's also the issues where I think people can actually add suggestions for new plugins. Is that right?
Yeah, if you have a suggestion for a plugin and you want to open an issue on GitHub, maybe I should show the GitHub repository quick. So you can get to it by clicking that link at the top of the documentation. So there's two ways to communicate here. One is discussions, which is where we do our Q&A. So you can see we get a lot of questions here on a daily basis, and we try to answer them in a speedy way. So this is where you could sort of ask, has anybody done something similar to this? So actually somebody a few days ago asked if we had a static and moving window self-paced reading example. So we pointed to this workshop. And the issues on GitHub is where we sort of track things that we actually need to change in the code, which includes occasionally new plugins that we're planning to create. So Becky has actually been working on a plugin that will support audio recording, allowing people to speak as subjects and the researcher to get that spoken data back. And so there's an issue open for a plugin that will create that. I don't think there's other, oh no, okay, so self-paced reading, not actually part of the distribution, but we'll probably add this workshop demo soon, and sort of a form plugin that we've been working on for a long time. 2015, wow. So yeah, it's been a while. Okay, what's next?
Great, thank you. I think maybe we have time for one more question. And this is actually a code-specific question. So if you don't mind, we only have a few minutes. Go back to your moving window plugin. And somebody had a question about what you're doing in the array.map. If you wouldn't mind explaining that.
Yeah, I can explain that again. That's
a JavaScript thing that we haven't seen yet.
Yeah, this is definitely the most, I think, confusing JavaScript function that I used here. What it's doing is we're starting with an array. So we've got an array that looks like this, where we have the dog chased the car as all separate elements. And then what map does is it calls this function that we've defined right here. So we use that anonymous function. It calls this function on every element of the array. So it says, apply this function to the word the, then apply it to the word dog, then apply it to the word chased, etc. And whatever the function returns, that becomes the replacement value, so to speak, for that element of the array. So what we're doing here is we're getting the word that we're currently at, like the dog chased the car, and we're also getting the position that we're currently at, or the index. So 0, 1, 2, 3, 4 for the different words. And then the logic here is just we're trying to, create this moving window where we blank out all of the words that are not the active word. So if we're at the active word, so if the index here equals the position that's active, then we just return the word itself. We don't modify it. We leave it there. But otherwise, if we're not at that active position, we just take this blank, the hyphen character, the dash character, and we just repeat it however many letters are in that word. And then that gives us the new set of stimuli. And then the last thing that I did was take that array and join it back together so that it was a string, so that it looked like the things that we were showing on the page.
Perfect. Sorry for asking that right at the end.
No, that's fine.
Not giving you enough time to explain, but thank you. Do we have anything else to add?
So just a reminder that that we do have Q&A 1 to 5 Eastern time on Thursday, and that's at that jsPsych discussion forum that I just mentioned. And of course, you're welcome to post questions here at any time, as I'm sure many of you have been doing, and we've been having a lot of great feedback and back and forth there. But if you 1 to 5 on Thursday, we will have Becky and myself and other members of our team. We will be active on this forum trying to answer questions as they come in as much as possible. So that's a great time to get sort of quick answers, or relatively quick answers to questions. Okay, so I think that's it. So thanks everybody for attending day 3 of our workshop. And we'll hope to see you at day 4, where we'll talk about the Pushkin framework for all that server side stuff that we have been ignoring so far. All right, take care everyone, thanks.
Bye.